I have one question here. Let's discuss how to solve this problem. Okay. Some hypothetical alloy is composed of 12.5 weight% of metal A and 87.5 weight% of metal B. If the densities of metals A and B are 4.27 and 6.35 gram per cm cube respectively, so this is the density for A, density for metal B, and their respective atomic weights also are given as 61.4 and 125.7. Determine whether the crystal structure for this alloy, either cubic, FCC or BCC. And also the question wants us to assume a unit cell edge length of 0.395 nanometers. So what does it mean by this? So this is your unit cell. The edge length, the length of this is 0.395 nanometer. In this question, you are asked to determine whether the alloy is either cubic, FCC or BCC, meaning you need to identify what is the number of atoms per unit cell for this alloy. If you can identify what is the number of atoms per unit cell, then say if you get your answer as 2 atoms per unit cell, then it's confirmed BCC. Okay, since we would like to know the number of atoms per unit cell, meaning we are looking for N. And how can we find out, or how can we solve for N, is using density equation. Rho equals to N A atomic weight over VC and then NA. Still remember this? Now this is for an element, but what about an alloy? So for alloy, we can use the same formula. It's just that we use the density we use for binary alloy, which is rho average, and the atomic weight also we need to use the atomic weight average, and the rest stays the same. N is the number of atoms per unit cell, VC volume of the unit cell, and Na is the Avogadro number. So what do we need to calculate here? We need to find out what is N. So you can rearrange this equation to become N equals to rho average A cube. What is A cube? A cube is VC. This is a cube, your unit cell, and the volume of the unit cell is just A cube. Avogadro number divided by the atomic average or the molecular weight. Okay, so it's just a matter of putting things into their formula. So for the rho average, you can use the formula 100 divided by Ca composition over rho A plus Cb over rho B, and then AQ and A. Where do I get this from? This is from my notes, alright? This is the formula to calculate rho average. This one. You can refer to the notes. And what is Ca? It's just the composition of metal A divided by the density of metal A plus the composition of metal B divided by the density of metal B, and then divided by A average. And also we have a formula to calculate the A average, which is 100 divided by position A over the atomic weight of A plus composition B over the atomic weight of B. And that's it. So number of atoms per unit cell equals to 100. Okay, and then this one 12.5 weight% divided by 4.27 gram per cm cube plus 87.5 weight percent divided by 6.35 gram per cm cube. Okay, so this one is for the row average, and then times the volume of the unit cell, so 3.95 times 10 to minus 8 centimeter cube. So this one I just convert from nanometer to centimeter, and Avogadro number 6.022 times 10 to 23 atoms per mole. All right, okay, so all of this divided by, so 100 divided by 12.5, the composition weight percent, over the atomic weight of the element A, gram per mole, plus 87.5 weight percent over 1 to 5.7 gram per mole. And then solving this, you will get around 2 atoms per unit cell. So if it's 2 atoms per unit cell, you will know this is the crystal structure of the alloy is BCC. Problem solved.